All right, hey guys. This is Miss Keys. I'm going to be talking through homework number 3. I know you guys had a chance to work on this in class, so if you feel comfortable with the ones that you did in class, feel free to skip ahead in the video to the ones that you haven't done yet. But I'm going to start from the very beginning and work all the way through. So let's start with this one. So we have 7.68 meters to centimeters. So I'm going to write down what I know, which is 7.68 meters over 1, because that helps us keep our fraction lines consistent. So 7.68 meters, so I know if I have meters on the top, I'm also going to want meters on the bottom. And I like to finish out with our units, so we know we're going from meters to centimeters. So then now I'm going to have my second line with meters on the bottom and centimeters on top. And now I need to think about how many centimeters are in a meter. So if you don't know this off the top of your head, that's totally okay. That's why we have our reference sheet. So I know that there are 100 centimeters in 1 meter. So I am going to put the 100 by the centimeters over 1 meter. So a good way to double check what you're doing is if you can cancel your units on the top and the bottom. That's how I like to think about it. I can cross them off and I know that I put them in the right spot because now I'm just left with centimeters on the top. But we have 7.68 meters times 100 centimeters. So 7.68 times 100, you can do that in your calculator. And that will give us 768 centimeters. Because we're just multiplying like this, right? We're taking the top divided by the bottom, but the bottom is going to be 1. So in this case, I just think about it as 7.68 times 100. Good. Let's move on to this next one. We have 48 kilometers to meters. So I'll start with what I know, 48 kilometers over 1. Sorry, I forgot that. We're going to go kilometers. Make sure if there's kilometers on the top, we have kilometers on the bottom. And we know we're converting kilometers to meters, so I'm going to put my meters on the top. Once again, look back at your reference sheet. How many meters are in a kilometer? We know that there are 1,000 meters in a kilometer. Once again, I want to double check to make sure my units are good. I have kilometers up here, so I can think about that as canceling. So I'm going to take 48 times 1,000 for my numerator, which gives me 48,000. And then if we look at our denominator, we see that they're both over 1 again, so we don't have to divide by anything. So that leaves us with 48,000 meters, which that makes sense too, right? Because we know that kilometers are bigger than meters, so we're going to want to have more meters than kilometers at the end. Let's move on to this next one, which talks about liters. So we're converting 9.76 liters to milliliters. So I know yesterday we were kind of having a hard time with what this meant. So liters is our measure for volume, whereas meters is our measure for distance. But our prefixes, like the little m we see here, is the same thing as if it were meters. So let's work through it and you'll see what I mean. We have 9.76 liters to start over 1. Times if we have liters on the top, we want liters on the bottom, and I'm converting to milliliters. So this is my initial setup. So now I have to think about how many milliliters are in a liter, because I know milliliters are going to be smaller. So I know that there are 1,000 milliliters in 1 liter. Double check my units here. Liters on top, liters on the bottom, those cancel. So now I know that I am going to multiply my numerator. My denominator, once again, is 1 times 1, which is 1, so we can kind of think about it more as a multiplication problem. So we have 9.76 times 1,000, which will give me 9,760 milliliters. Good. What about if I wanted to write this one in scientific notation? So I'd start with my decimal point over here. How many times would I need to move it? 1, 2, 3. So that would leave me with 9.76 times 10 to the 1 to 3rd power. So that's how I'd also write that as milliliters. Good. Let's work on the next one. 90 milligrams to grams. We start with 90 milligrams over 1. And if we have milligrams on the top, we want milligrams on the bottom. And then grams goes on top because that's what we're converting to. How many milligrams are in a gram? I know that there are 1,000 milliliters in 1 gram. So up here, I'm going to do 90 times 1 divided by my denominator, which is 1 times 1,000, so 1 times 1,000. So that's 9 over, then I put that into my calculator. Hopefully you can see it. Maybe not. Let me see if I can refocus it really quick. And if this, nope. Okay, well, that's not gonna work. So just so you know, in my calculator, I have 9 over 100. And the way I like to convert that to a decimal is I go to menu, number, and convert to decimal. And that will give me 0.09 grams, which that 0.09 is a lot smaller than the 90 that we had before, right? But that makes sense because we're going from milligrams, which is smaller, to grams, which is bigger. So we're going to have a smaller number for grams because 90 milligrams is not that many grams. Good. Moving on to this next one, I'll move this up a little bit. We have 4,872 meters to kilometers. So I'm going to write down what I know, 4,872 meters over 1 times, if we have meters on top, meters on the bottom, and kilometers. So how many meters are in a kilometer? I know that there are 1,000 meters in 1 kilometer because kilometer is the bigger of the two. If I'm looking here, make sure my units canceled, we're good. So I'm going to do 4,872 divided by 1,000. And as a decimal, that gives me 4.872 kilometers. Good. Ooh, this next one's one of my favorites. Super excited. All right, so this one we're going from 879 centimeters to kilometers. So when I was talking to you guys about this yesterday, this one's a tricky one. This is the first two-step conversion that we're going to do. So if I asked you how many centimeters how many centimeters are there in a kilometer, that's a tricky question. I actually don't know the answer to that off the top of my head, but I do know how many centimeters are in a meter, and I do know how many meters are in a kilometer. So for me, that means it makes more sense to convert them to meters before moving on. And I know that sounds kind of scary because it's a two-step conversion and we haven't really seen that until right now, but it's basically the same process as we're doing before, I promise. So let's start with what we know. That is what we've done for everyone before as well. So we have 879 centimeters, and I'm going to convert this to meters because I know how many centimeters are in a meter. So we have 100 centimeters in 1 meter. I forgot to put this over 1, I'm sorry. So 100 centimeters in 1 meter. So we have two choices. I'll do this first one in 2 separate steps, and then this next one I'll do in 1 continuous line, which is going to look a lot like something that you guys have done in chemistry. So here we have 879 centimeters times 1 meter over 100 centimeters. My units cancel. That means I'm good to go. And that is going to give me, that is 8.79 meters. Is that what I'm looking for? No, I'm looking for kilometers. So now I'm going to take those 8.79 meters that I just found, and I'm going to put meters on the bottom this time and kilometers on the top. And here you see meters are on the top, so meters go on the bottom. I know that there are 1,000 meters in 1 kilometer. So that means that I'm going to take 8.79 divided by 1,000, and that will give me 0.00879 kilometers. And that looks like a prime candidate for how we would write this in scientific notation. So for scientific notation, I know that I want my decimal point between the first and second non-zero digits, so I'm going to go 1, 2, 3. So I have 8.79 times 10. I move my decimal point 3 places, but this is a decimal, so I know it's going to want to be a negative exponent. So 8.79 times 10 to the negative third kilometers. Very nice. Good. Boop, boop. All right, we're kind of running out of room, but this last one isn't too bad, so hopefully this makes sense. Separate sheet of paper, amazing. And this is where there's not a lot of room, so if you think you need a separate sheet of paper, please do that. It'll be really helpful. So let's look at this next one. We have 12 kilometers to centimeters, just to rewrite the problem. Good. So once again, this is the same idea, where I don't know how many kilometers are in a centimeter, but I do know how many kilometers are in a meter and how many meters are in a centimeter. So we're going to go like that. Last time we did the problem in 2 separate steps. This time I'm going to show you how you can do it in one line if you want to. That gets a little confusing, so I'll also do it the 2-step way. So we have 12 kilometers. If I have kilometers on the top, I'm going to want kilometers on the bottom, and I'm going from kilometers to meters because I know that conversion off the top of my head. Good. The next one, I'm trying to get to centimeters at the end, right? So I know that I'm going to need, if I have meters on the top, meters on the bottom, and then centimeters on top. So we're going from kilometers to meters, and then meters to centimeters. And the same thing applies where I can check to see if they cancel, so I get what I'm looking for at the end. So kilometers cancel with kilometers, meters cancel with meters. So that should work. So let's see. How many meters are in a kilometer? I know that there are 1,000 meters in 1 kilometer, and I know that there are 100 centimeters in 1 meter. So notice how everything that I have that's a number is in my numerator. So that means I'm going to have a really big number. And that also should not be surprising because I'm going from kilometers to centimeters, right? So kilometers are really far. That's how we talk about like how far we're going to drive our car. And if we're turning that into centimeters, which is one of those things we saw on our meter stick yesterday, that's going to be a lot of centimeters. So if we multiply all this together in our calculator, we are going to get 1,200,000 centimeters, which is a lot of centimeters. But again, that's not surprising, right? Because we're going from something that's really big to something that's even smaller than a meter. So this is another prime candidate for scientific notation. So I know I'm going to want my decimal point here because it's between the 2 non-zero digits that I have. And let's see, so I'm going to have 1.2 times 10 to the what? 1, 2, 3, 4, 5, 6. 1.2 times 10 to the 6th. Good. Let's look back to our homework sheet. We have one more. I'm going to write C extra sheet on this one in case people are scrolling ahead. Good. So we have 8 milliliters to liters. I'm going to start with my 8 milliliters that I know, put that over 1. And then I can go from milliliters to liters because we know milliliters to liters, or our milli to our base unit. So there are 1,000 milliliters in every 1 liter. And that will leave me with, when I put that into my calculator, 0.008, oops, not milliliters, liters. Perfect. That's it for our unit conversions using our prefixes. Now we're moving on to time conversions, which is something a little bit different, but is also really good. So let's work on this. So we're going from 5 hours to minutes. So again, we start down with what we know. 5 hours, I'm going to abbreviate hours, HRS, over 1. How many minutes are in an hour? So for every 1 hour, making sure again that we have hours on the top, so we're going to have hours on the bottom. There are 60 minutes. And that's it, right? We're going from hours to minutes. Our hours can cancel, so we're left with minutes. 5 times 60 divided by 1. Again, the ones don't really matter because it's just 1 times 1, but 5 times 60 is going to give us 300 minutes. Let's now do 7 days to hours. So we start with 7 days over 1 times, we know we're going to have days on the bottom and hours on the top. So 7 days, how many hours are in 1 day? We know there are 24 hours in 1 day. Double check to make sure I'm doing this okay. Days cancel with days, so I'm left with hours. So 7 times 24 is going to give us 168 hours. Good. Last one on this part, super exciting. So we have 80 seconds to minutes. So once again, I start with what I know, 80 seconds over 1 times 5 seconds on the top. I'm going to want seconds on the bottom. And then I'm going to have minutes because that's what I'm going to. How many seconds are in a minute? There are 60 seconds in 1 minute. And remember that our 60 goes with the seconds because that's the part that's going into the 1 minute. Let's double check to make sure we're right. Our seconds can cancel. We have minutes left. And we have, so here we have 80 times 1 divided by 1 times 60. So 80 divided by 60 is going to give us, it's a repeating decimal, but we'll go with 1.33 minutes. Which brings us back to our rounding, right? Because we know it's going to be 1.33333. So if we're rounding to our hundredths place, we're going to look at this digit, which would be another 3, and we would choose to keep that a 3 as a throwback to an earlier lesson. So we'll go with 1.33 minutes. Good. So now we're down to our 2 ACT problems. These are actually both really cool problems. I like this a lot. So the mass of particle P is a lot of zeros, 847 grams. In scientific notation, what is the mass in grams of particle P? So first of all, let's look at this. So we see that our decimal point is all the way over here, and this is a lot of zeros, but our decimal point's at the beginning. So is this going to be a positive or a negative exponent? We know that it's going to be a negative exponent because it's a really small decimal, right? So I only see 2 negative exponents here. So I can cross out C, D, and E because those are all positive exponents. So I know that it's either going to be A or B. So now we just have to count how many zeros we have and where we want to put our decimal place to figure out if it's times 10 to the negative 11th or 10 to the negative 10th. So let's count together. So this is a group of 3. So we have 3, 6, 9, 10, 11. Let's do that one more time. 3, 6, 9, 10, 11. So it's going to be A, 8.47 times 10 to the negative 11th. That end part's a little bit tricky. Sorry, I was holding up on that because they're so close together. But we know it's going to be A. Let's look at number 14. I actually think this is one of the coolest questions I've ever seen about scientific notation, so I'm a little excited, but that's okay. The decimal representation of 3.9 times 10 to the negative 93rd is, and then it gives us a whole bunch of options. So looking at the format, it either starts with a decimal point or a negative sign. So if it starts with a negative sign, that means it would be a negative number, right? But have we ever seen a scientific notation where a number that starts as a positive becomes negative? No, right? Because 10 to the negative third means we're going to be moving our decimal point a whole lot of times. It says nothing about whether it's going to be a negative number or not. So that means I can eliminate H, J, and K because those are not going to be negative numbers. So now we're left with F and G. So those are actually, this is the tricky part, right? So we have a decimal point followed by 92 zeros, then the digits 3 and 9. Or for G, a decimal point followed by 93 zeros, then the digits 3 and 9. So I'm going to erase my lines from before. So we're left with the option of 92 or 93 zeros. So obviously our exponent is 93. So it might be tempting to put that down as our answer, but it's not, right? Because we can't just start moving the decimal point. We have to get our decimal point past this 3 first, right? So we go from here, which is 3.9, and move it 1 over, and then we can start moving it over for our 90, however many zeros, right? So since I had to move it this one time, that's using up one of my 93, right? So that means that I only have 92 zeros after this decimal point. So it's going to be F. Once again, because I moved my decimal point one time past the 3, and then now I have room to move it over for my 92 zeros, which I'm not going to do because I don't want to do that, and you wouldn't want to watch a video that long because we're at the end. So that makes no sense. But thanks, guys. If you have any questions, please come see me or Miss Avra, and we'll be happy to talk you through how to do any that you had a question about.